Question 1.8a asks us to analyze the possible decay modes of omega minus. For context, the omega minus particle is found at the very base of the baryon decouplet. The omega minus decays into a lighter baryon and a meson. In order to determine the possible modes that omega minus decays into, we need to find combinations that allow us to conserve charge and strangeness. So omega minus has a charge of -1 and a strangeness of -3. The two combinations that do this are the kaon minus particle and the z naught particle, as well as the kaon naught, anti-kaon naught particle and the z minus particle. And you'll see that both of these, their charges add up to -1 and their strangeness adds up to -3. So all is fine and dandy. But if we actually look at the masses of these constituent particles and what they add up to, it's actually it's a bit of a problem. So if we add up these two particles, we'll get, using the data from the Particle Data Group website, 1,808 megaelectronvolts per c squared, and with this combination you'll get 1,819 megaelectronvolts per c squared. And this is a problem because the expected value or mass of the omega minus particle is 1,680 megaelectronvolts per c squared. So these combinations are actually far too heavy for our expected mass value of omega minus. And so there's an inconsistency, and it turns out that later on it was discovered that the omega minus particle does decay, but through a much slower, weak interaction. Okay, so now we're going to be discussing 1.8b. So 1.8b asks us to refer to figure 1.9 in the text, which is a bubble chamber photograph. And so we are asked to measure the length of the omega minus track in order to determine its lifetime. So this is a very rough estimate, of course. I took my ruler, I put it up against my screen, and I got the measured length of the omega minus lifetime, which was 3/8 of an inch. Converted to SI metric, it's 0.009525 meters, which will act as our distance. So, of course, we plug it into our trusty V is equal to dt equation, rearrange for t. And so we will estimate or approximate V as 0.1 the speed of light. And we put it into our calculator and it spits out an answer, which is 3.18 times 10 to the minus 10 seconds. And that's our very rough estimate of the lifetime of an omega minus particle.